So let's look at another example where we're solving a multiple angle equation. Here I have this equation given where I'm solving over the interval between 0 and 360 degrees. So each of these angles are both of these angles are 2 theta, so these would be like terms, so I'm going to kind of address the interval issue for a second. If theta is on the interval between 0 and 360, then 2 theta is on the interval between 0 and 720. Okay, so this right here tells me I'm going to go around twice. I'm going to go 2 revolutions around. Now that I understand what interval I'm looking at, let's come back over here and combine our like terms. Since these are the same angles, we can combine these. They would be considered like terms. So I'm going to add sine 2 theta to the right-hand side, and I end up with 3 is equal to 10 sine 2 theta. Then I'm going to divide both sides by 10, and I have the sine of 2 theta is equal to 3/10. So let's just look at this for one moment. The sine of some angle equals 3/10. Well, I don't know, this is not a common angle from our unit circle, so that tells me right there I'm going to need to use my calculator to solve this. Second, I know since this is a multiple angle, when I take the sine of some angle and get a positive value, then I would be looking for angles that are occurring here in quadrants 1 and 2. So again, if I'm looking for 2 theta, then I'm going to go around the circle 1 time and around the circle 2 times. So I'm looking for a total of 4 solutions, 2 being in the first quadrant and 2 being in the second quadrant. So now on our calculator, let's let the calculator find the inverse function. So we say 2 theta is equal to the inverse sine of 3/10, which in my calculator, first of all, I need to make sure I'm in degree mode. So if you're not already in degree mode, you need to change it. Since I'm dealing in degrees, we want to find the sine in degree mode. And now I'm going to take second sine, and I get the inverse function, 3 divided by, let me scoot this up for a second so I can put the 10 on there. So inverse sine of 3 over 10, and I end up with 17.5 degrees. So what did I find out? I found out that 2 theta is equal to 17.5 degrees, and that is the angle right here in the first quadrant. But because I need this angle over here in the second quadrant also, then all I have to do is take 180, because that's halfway around, subtract off the 17.5, and I end up with 162.5 for this second value, or the value over in the second quadrant. Now these are the 2 angles for the first revolution. So to get the angles in the second revolution, or the remaining solutions for this, I can just add 360 degrees to both of these, and it will get me back to the first quadrant the second time around, and the second quadrant the second time around. So we'll add 360 to this, and we get 377.5. And when I add 360 to 162, I get 522.5. So those are my values for the first and second quadrants. But because I need to solve for just theta, I'm going to go in and I'm going to divide all 4 of these angles by 2, giving me 8.75 for the first angle, 81.25 for the second angle, 188.75 for the third angle, and 261.25 for the fourth angle. And those are the 4 angles that are on the interval between 0 and 360 for theta. That would be a solution to this problem. So remember, when you find an inverse function on our calculators, remember what the calculator is returning for us, and then remember how to get the remaining angles that you may need.